Okay, so the problem we got, yeah, this is the problem, right? So, mm, you have any question on this data? Meaning, we have this data, has this. So, first task is actually you need to somehow clean up the data first, that is fine. And later on, you have to bring this, I think, mileages into one number. If they have some different unit, might be need to convert if you able to. Otherwise, you can use that number only. And yeah, data cleaning piece. Find the outliers, remove outlier, fill these numbers, blank ones. Any error is there, and if you able to group these names, also very good. And that's all I think. And yeah, encoding piece also like machine learning algorithm. They only understand numbers, right? So somehow you have to change these LPG to some numbers. You can call this LPG as group 1, category 1, petrol as category 2, and diesel as 3 categories. So you can replace this number by names by number, something like that you have to try first. And yeah, that is correct. You are going to do the analysis. That is like you can yearly basis count what is the sales of each of the car,
What?
what type of car it is selling. Yeah, who is morely selling, individuals are coming more or dealers are coming more. These types of question you can definitely get answer. So that is initial exploratory analysis. Easy pieces like yeah, get those information.
Rishi, like you mentioned, like we need to convert these data into a numbers, right?
Correct, correct.
So it's like any kind of example. I don't know how to convert this as numbers.
So yeah, we can apply something function, right? Apply function and create dictionary saying diesel is one. It will replace for you. So yeah, can show you also like mm, yeah, something like this. Yeah. So I think yeah, this is very straightforward. Yeah, can try. If not, I will. Yeah, other way is how to do encoding. You can search. This is different encoding. Otherwise, yeah, no, not this one. Cato categorical encoding. Yeah. So there is one method actually in Python. It will do in one shot, kind of. So first you need to find what type of data, and I think yeah, yeah. Then like this actually. So 4 is replaced by 2, 4 numbers. 2 should be replaced by 2. This 4 should be replaced by this 4. Something like this. Here you can use this cleanup. First create the dictionary, then use the replace function to replace it.
Okay. Before doing this activity, like replacing the numbers, we should be having a correct
Okay.
data set, right? Like without
Yeah, yeah, correct,
any.
correct. So first step is you have to create the data set clean as soon as possible, whatever you can find out. Start doing it, then you will realize, yeah, this data is wrong, then you will go back and do again. You can read this also, like encoding, different types of encodings are there. One hot encoding, categorical encoding, label encoding, and like this. This is like your encoding. You know, like this 4 should be replaced by 4 number and all. Find and replace. That is. Second is like label. You are just labeling, yeah, convertible to be 0, hard top is 1, something like this. So think which type of encoding is better for these types of data. So in this individual, you can say individual is one category and dealers are second category. If you find third one, you can replace the third category. Similarly, manual and transmission or automatic, you can say 1 and 2. But I think first, second, third honor you have to, yeah, say correctly. Like first is 1, second is 2, and third is 3. If there is fourth and other, how you will represent. So think of it also. So yeah, these are only things. Yeah, and
So one
similarly, diesel and petrol also you have to replace. Remove
in L,
CCs, KM.
yeah, yeah, that was my question. Like there is a L column. I don't know what is that actually.
Yeah, for
Something.
time being,
So
yeah, torque is there. What is the speed of a
how do we
vehicle?
segregate like whether this column is required for this data set? Since it's like should
You
we
can
ask?
ignore also for time being, no issue. But if you can somehow make it usable, then good for us. It's not straightforward. Yeah, I understand. So we will let's go through one small use case how we do regression analysis. Then we will go theory. How
Okay.
okay. So I have I think already one. Yeah. Course that is, yeah, regression. We will talk on this only. So the first question is what is regression? You can say regression is something which you want to get a relationship between dependent variable versus independent variable. That is first thing. And yeah, I think small slides also I have. No. Yeah, let's read this one. So, what is regression is? Yeah, first theory, then we can go into that question. So, what is simple regression? So, there are two types of variable it will have. One is dependent variable, one is independent variable. Independent meaning that is the input you know every time. So, in our case, in this example, your independent variable are all things, right? You know your cars when it is manufactured, what is the car name, car configuration, everything you know, how much kilometer is driven. These are independent, they are independent to each other actually. So your selling price is acting as a dependent variable which actually depends on all these variables, right? What is the car make it is, how much it is driven and all. So in that way you can make a differentiate. We should have two type of things to do regression model. You should know one dependent and one independent. So it is actually trying to build one relationship between how those variables are changing. If my make is going to change, how your selling price will change. What is the explanation we want to find, like how or what is the cause or relationship between them, which is making the dependent variable vary if I change something. So change in the independent variable that results to change in the, sorry, change in the dependent, yeah, result from the change in the independent variable. So some amount of independent variable, how much. So suppose kilometer driven, right? So one car is came with 10,000 kilometer driven. If you increase your 10,000 kilometer driven to 12,000, how much your selling price will increase or decrease? That is the relation you want to find. And while doing this model, you should also check strength of this relationship, meaning how they are they strong or not. That can be driven from the error calculation. Like error are very less, then it's a strong relationship. You can say one thing. And there are matrices. We will check how we calculate the error. And statistical significance also. They are should be there are some set of assumption like they should be independently normally distributed and all. Their error should be actually, and some data assumption is also there. So this is the regression model. You can let's talk about like how and where we apply this. So one is like, yeah, sometimes in a region or anything we want to predict a gas oil price. So that is also one type of regression, gas price of a retail actually. So it's like in petrol pump we are selling some petrol or something, right? Gas. That price in when you go to petrol pump you might be finding yeah 80 rupees it is selling. But your that 80 rupees is actually depend on the crude oil price, right? You know the international market they have some selling price of in the barrels they calculate, and based on that actually your price are dependent. But this is only not the factor actually. While we go for this crude oil prediction or oil petrol price prediction actually, so that is actually dependence on crude oil. This is very straightforward one relationship. But yeah, there are some problem which people will solve for crude oil prediction actually. So this is not in our scope kind of. It's very much dependence on geopolitical reason. But yeah, but your petrol station, if you go in Bangalore, some petrol pumps and buy some oil, then it is definitely depends on the crude oil. So in that case, you can say my petrol pump's price is dependent on crude oil price, which is crude oil is acting as your independent. Similarly, your income, most of the this question, many of the data set you will find, any of the employees actually depends, its income depends on various things. Those are like how much hour he is working, what is her or his occupation, what profile he is working for, his male or female, how many years of experience, and all those things actually, and even the reason. Maybe in the Bangalore you are getting some salary supposing 10,000. If you go to Bombay, then its salary will be some 12,000 kind of thing. So these are acting as your independent variable, and your income is acting as a dependent variable. So such problems in how to say industry you will find they will come up with some data set which will have some dependent variable. They will ask to predict something or find some relation actually. Are is this acting as a dependent and independent variable? Can you derive some relationship between them? That is your main first focus will be. So similarly, yeah, price of product of anything, quantity of sale, how much it is selling, those also depends on the. So sometimes you can say if you have sale and all, your price quantity selling prices or selling quantity will be very high, or produce is also dependent and independent to each other actually. This is economics actually, right? If price is less, so people will buy more.
Yeah.
Correct. So these types of relationship in retail sector definitely you have to find actually. In retail sector they will actually solve this problem very rigorously, and this is how this retail market Amazon and Flipkarts are making money. They are really sitting behind and doing this machine learning stuff to predict the exact price so that they can earn profit also and people will buy for also. And based on that only they are deciding how much to decide give the offer actually. So there are some companies which is primarily focus on this, and they have various many products actually. Yeah, I forgot the name. Yeah, Some of the company they do this price prediction. So you can see one data actually. This is I think long time back, some your local price versus crude oil price they are plotting, and you can see there is straightforward correlation. The trend is similar to the your this is local price at your petrol pump or local area of any data set it is. I'm not sure it is, obviously it is US data, and year by year you can see the price fluctuate according to the crude oil price. So there are two types of model it can have. Like simple one, we call this as a bivariate. One is input, one is output. When you have multiple, more than one variable, we call that multivariate. This is like second question you can get in interview, asking how you differentiate multiple regression and all. And similarly, model with simultaneous relationship. Obviously, if price is lower, you will be selling high or yeah, producing high kind of. And yeah, these are like inversely proportional actually. So if your sorry produce is very high, your price will be less. If your produce is very less, price will be higher. That is like also again economics piece, demand and supply kind of thing. So this equation, whatever this, now we represent them into one mathematical equation saying our independent variable, sorry, dependent variable, this is somehow related with beta plus beta 1 times x. So our model's aim is finding beta 1 and beta 2, and there will be some small error, that is we are representing as epsilon. And this is like your uh, third piece of this regression. Obviously they will ask anyone, meaning in the interviews also, how we calculate beta 1 and beta naught and what we call them. This is actually intercept we call. Actually, you will find, yeah, beta naught is intercept and beta 1 is nothing but slope of a line. So the idea here is you decided this is a regression model, but when you able to say this is linearly dependent, meaning when you increase something like this, x and versus y, in here you will plot the independent one, here you will plot the dependent one. If you plot these values, some dates and all, dotted lines, dotted points actually, then you will find somehow this data is actually linearly dependent. This is our assumption. Like data is always, meaning for this scenario, it is linearly dependent. We will try to fit this line in that data. You might be remembering, we did this pair plot, right? There was one straight line used to come.
Right.
Yeah, so there was LM we are actually using linear model. So that is where we are trying to find. So we need to now, so see what is the advantage also. If you know beta naught, beta 1 and epsilon, for time being you can ignore. This is random and unexplained error component, which is not going to, we not care much on this, but we can calculate that also. But you can see if you know beta 1 and beta naught, put x value, you can get y actually. So in our case, you can say for assuming selling price of this car, you plot it with kilometer driven. If you put some 10,000, you point got this value. So 20,000 you got this value, 30,000 you got this value. So suppose you put 40,000, you can put here value 40,000 kilometer driven in based on that beta 1 and beta 2. Then you can calculate, yeah, my selling price could be this value, some suppose 4.5 lakhs kind of thing for that particular car. So something like this we are targeting here.
Rishi, here the beta value, we will be knowing x value, we will be knowing the y value, like which column to be used or which So data to be used. For
Correct.
this
You
beta
have to
naught and
decide.
beta
Yeah.
one, for this
So
beta naught and beta one,
you will
they
get
are
from
like
the model beta 1
model.
and beta naught and beta 1. You will calculate using model.
Model in the sense on the matplotlib whatever.
Math. Yeah. So for time being, you can assume we are doing some maths behind it to get the value of beta 1 and beta naught. But actually, we might able to derive also. That is very straightforward. It is how you will get the beta 1 and beta naught. No, no, actually, there are formula which will actually calculate beta 1 and beta naught for you. But in Python, it is already built in, right? Using sklearn libraries, you can calculate this beta naught and beta 1. And it will have more statistics component also, saying that is it really a relationship or not? Is it a strong or not? So two things. You can either check with the error thing, and second thing is statistical significance relationship. Based on that, you will make as a saying that is this a really a valid relationship or not? This regression model is correct or not? Based on those values, you will see. So yeah, just go through this line, this slide. Our main one more assumption is here is it should be linear or a straight right relationship between x and y. I just come back here. Yes. Any questions now?
Here they have mentioned like the slope of line B1 and the B0. This one in this diagrammatically represented one, we have marked X and we have marked Y, and we have got a straight line.
What
What are
is,
the
yeah, b1, right? So
yeah.
b1 is slope of this. So slope, how we calculate this one, right? Saying this piece, the triangle's hypotenuse, we call this as a slope. So this is beta 1, and this we call this as a intercept. Sorry, it should be like this. Wait, I should delete for time being. Yeah, that is beta naught. Yeah,
Okay.
this piece is beta naught. I think in the later class, figure maybe, yeah. So the idea is you will able to represent this model into this equation. You have the data of x and y already from the sample, right? See, so what you will do is you will try to plug in that value. So saying, uh, oh, okay, sorry, yeah. So actually, this is our expected values, but based on the sample data. So see, one thing is you will always have some sample, right? You cannot exactly make a perfect relationship between them. Correct. In the end, you will have limited sample, either 10,000 sample or 12,000, 20,000, or 1 lakh. But it is not exactly representing the X and Y relationship. So there will be some error. So we are saying that based on this x and y values, we will obtain estimate this beta naught. So we say, when we say estimate, it is like we are close to beta naught, but not exactly beta. So b1 and b2 is actually estimate of beta naught and beta 1. And this we actually use one method, that is least square, or any other method. So least square L, this should be SSE, least square error method. Yeah, LSE. Or there are many other methods also we can discuss for later. Yeah. So this is y naught is exact value, y hat is estimated value. So you will say y hat is like predicted value for you for any of the dependent variable y and associated with x given the linear model. So these are also some you can say terminologies where you want to. So your assumption is I should get beta naught and beta 1, but you are happy to get estimated. It should be closer to beta naught. So b naught and b1 we are getting from the model. This is your result of estimating from the model. Correct. So see, what I am saying is this 4.5, when you put some value, right, 40,000 kilometer driven, this 45,000 is not exact value, right? Maybe you can sell at 4.5 lakhs, or maybe you can send at 5 lakhs, or maybe you can sell at this 4.8 lakhs. But this is only estimate. So that is why when we are estimating, we are representing that value as y naught, y hat. This is only one assumption, and exact value you don't know actually. What is that exact value? So that is how we,
Rishi, suppose the
yeah,
45,000 that we are trying to get from the first one, like uh, in this expression, we are trying to get 45. The later one with the y hat, what we are doing is that
no,
that is the
actually that
actual.
45,000 is nothing but y hat. Yeah. 4.5 lakhs
Okay,
is
first
y
we
hat.
need to
Yeah.
do this.
Yeah,
First, we
this
need to
should
do
be the
y hat.
first step, and that is actually theoretical representation only. Yeah. Your predicted is always represented by y hat.
Okay. Which is
Hmm.
like a closer value, like it the
So,
product might
but
be
why
under
you
45
don't
or
know
40.
exactly, right? What is the exact value? If you put the exact beta and sorry, okay, okay, yeah, exact value of beta, exact value of beta 1, and there should be some error term, then only you will get exact value of y. But you don't know why. You are saying let's closely estimate this beta naught and beta 1 using some method that we told, la least square error method, LSE, and we will calculate the beta 1 by beta 1, sorry, b1, and beta naught by b naught. This is our idea. So let's see, I think there will be some derivation we can make more sense out of it. So yeah, similarly we will have, so the question is why they will be related also. What mean, what is the cause? Cause in the sense there is two term we use, correlation and causation. See, there is one classic, what we say, uh, correlation doesn't mean there is a causation. Causation meaning what is the reason which making X and Y have some such relationship. So you can say, how to say this? Is, yeah, sometimes you can say this medicines act or reduces your temperature and all, but that cause you are saying, right, like with the help of medicine only you get cured. That causation is not necessary. Or one more example can be, so tomorrow it is raining, but the rain is actually, it not depends on today's weather, but actually it is depending on some other factor. So those predictions and the causation, you cannot make a exact saying this is only the causation. That there can be multiple cause, but you are actually speculation about the possible relationship and trying to based on the correlation. You are saying yeah, that can be a possible reason to occur such uh, relationship. You able to understand? See,
Yeah,
what I am
actually,
trying to say
causation.
is your price is, suppose for your for this example you came up with 40,000 driven, right?
Yeah.
40,000 driven, kilometer driven, that is one parameter you got. Yeah, you came with your car 40,000 driven, and based on this method you estimated this price should be 4.5. But why 4.5? This kilometer driven cannot calculate your selling price, right? No, not only this factor, right? Why this will be only factor? Maybe your car's look is very good, then you might be able to sell this as a higher price, 4.8 lakhs. Or maybe your engine condition is very good, then you can sell this as a 5 lakhs. So this 4,000 or whatever you say, like uh, correlation, right? There was some correlation between kilometer driven and selling price, but that is not telling you the exact reason of why it is 4.5. That is causation. What is the
Okay.
cause of getting 4.5? But correlation is there,
It's very,
but it doesn't mean there is a causation also. This is only driving that value. So in statistics there is proven concept, meaning you should not only rely on data every time. There can be multiple cause also. That is one good way to say this.
okay. Let me put in
Correlation,
this way.
yeah,
Like
correlation
the
doesn't
kilometers
mean
with,
there is a causation.
like the kilometer driven is a correlated with the selling price. As I stated. But there might be other factors also which can turn for the selling price changes. So
Yeah,
that is the
correct.
causation. Right? Okay. I got
No, actually you want to find the exact cause. So, but the idea is, wait a second, I should tell the, yeah. Correlation doesn't imply causation. That's all we want to say. That is only idea. This is like, yeah, in statistics, this statement is very much have significance, meaning correlation doesn't mean there is a causation, meaning it is not only, or it is the not the reason why your selling price is less or high. There can be many really reasons. So that is only causation we are saying. So in economics, you already know price and all are this typical relationships, and they are statistically proven. So you can expect those relationship. Economics is their price is increasing, then your selling quantity will decrease. If your discounts are higher, your selling quantity will decrease. But see, these are general, but you can say because the season is like this, that's also a reason. That's why it is, you may say, I given discount this month, that is why you are selling, your goods are selling too fast. But there can be many reasons. That is why this causation and correlation concept come into picture. But there is some relationship, so we just want to find out that some relationship using this linear regression models. That's all. So historical studies, meaning based on the past relationship also, like for time being it is for Mondays or Sundays it will be higher, in Tuesday, Thursday, Friday it will be lower, and then Saturday, Sunday it will be higher, something like that. We come into time series format, and similar studies we can find for different samples related issues. Theoretical reasons of regression is empirical relationship and theoretical explanations. So there are theoretical formulas and all versus P, VT and all. So those already have some empirical relationship. So you want to check, meaning that empirical equations or relationships are really a good estimate using reason. Meaning there are some relationship already established using empirical formulas. You just want to validate them. So you can use regression also there also. Yeah, so you try to have some relationship for such behaviors. That is how you want to try, meaning you want to have some estimates of regression actually, regression analysis. So it is, I think, yeah. So what is the use? I think just now we talked like there was some examples. Similarly, we can have like, so one is like you want to check amount of change in the dependent variable versus independent variable. So suppose you change the your that for our example kilometer driven or mileage also is one more parameter. Hello, hello Ritesh.
हाँ भैया।
Are you able to understand?
थोड़ा बहुत समझ में आ रहा है।
Okay.
Hi Rishi.
Yeah, hello. So
Sorry, I
yeah,
got totally
where you got disconnected. Yeah, so we told there are many use cases of this regression. Like you only interested in finding how the change versus change in this dependent is actually going to affect the independent. So yeah, so I was saying there are mileage also. Supposing mileage increased by 10 kilometer per hour. So how much your price can be increased for that case? So like estimating the elasticity, return of return in the investment in the human capital. There are some such things which you want to attempt to find the cause of any phenomena. Like so, yeah, various factors you want to try. Like why this today weather is like this, or why health or health of peoples are getting so low, kind of thing. Prediction and forecasting the sales, economic growth, selling quantity, promotion, everything is like kind of another regression examples. support or negate theoretical models. That is also where you want to check. Like you, with the theoretical formula and all, yeah, many experiments, you establish some formula, and that formula to be proven correct, or that formula is correct or not, then what you will do, you will do regression analysis and try to support that or reject that theoretical model. Similarly, you will modify and improve that model based on some explanation of phenomena. That is also one case. Let's go to one example. We have some data set saying how many hours a person is working versus what is the income. This is our data. So first step is something, if you want to find some relationship between such independent and dependent, which one is independent and which one is dependent here?
Income is dependent on the hours of work.
Yeah, correct. So income will come on which axis? And
Income is, it is dependent y axis.
correct, hours per week will be here. We will plot like this, and
It's
income is in here. Yeah. And what we will do, our first step is, yeah, finding out which is dependent, independent, then trying to plot them. Now, for second step, then there is one example actually. You can see 2 hour, 200 hours per week. No one is going to work that much. So this is wrong data. You should remove such data also, right? 200 week
right.
hour is there. It can be possible. Yeah, 24 into 7. No, it is 168, right?
So it's given more. So it's a wrong.
Wrong data. Yeah, correct. We should remove
168.
such data. So you should use your common sense also. Like, yeah, that is possible or not. We should remove such data and try to plot them. Now, if you plot, you can see there is some trend, right? As your hours per week is increasing, at least your somewhat in this income is also increasing. The person who is working like 50 hours a week, he is getting some 25,000 for this work actually in summer. This is summer work. Maybe some laborers are working too much in hour, or maybe that is supervisor, or yeah, he is working too much. That's why he is getting something. So there is some trend is there. So that is what our idea is. Suppose I ask you, because you have only value of kind of you say 45 is there, but you can say 43 is there. Suppose I ask like, yeah, 45.5 hours I want to work in a week, what should be my income? That is our question can be. Or suppose a person comes with saying want to work 40 hours a week, how much salary you will give? So based on data also you can try to plot, yeah, there is some relationship, I will, yeah, at least I will give this much. Or you can predict some range also, 10 plus 10,000 or some 1,000 plus minus kind of thing. Based on that you can start your negotiation. Suppose you are HR of that company, so you will try to plot such graphs. Then when you plot this graph, you can see we find this y hat should be equal to, based on maths, this equation. Why this by it is negative of it, because maybe if you are working very less, you will be not earning anything. It should not be the case. But in this example, it is coming minus of 2400. That is, this piece is beta naught, or sorry, B naught. We will use here using this terminologies. It is P, sorry, B naught, and this slope is nothing but B1. And we have some significance level. So what we told that significance level should be lesser than some value. We put that. So level of significance, if you remember, we used to set. That is alpha we used to call, yeah. In our cases, it is 5% generally, and 5% is nothing but 0.05. And from statistical table and all, we will find it is lesser than this, right? This value is less than 0.05, sorry. So we will say this uh, relationship is kind of correct relationship, or it's a valid, or based on our significance data, we can say, yeah, this is making some significance, or yeah, it is a valid relationship. So this type of
Okay, so
analysis
this
we used to
minus
do.
value and 297.
Yeah, 297 into x plus so
No,
minus of 246 1.
how that is,
Yeah, that is not possible
how this
actually.
value is taken.
That value is,
Go ahead.
no, that value is
No,
coming,
I'm
but
not
it
able to
should not be
understand the value
negative.
that
Yeah,
they are given
correct.
for validate.
Anyone's income should not be negative. Even you work zero, I think you will not get any salary. That's all. So
Yeah,
later
that
on,
could
you
be a
can
zero over
modify
here.
this equation saying if x is lesser than some value, you will use zero. Kind of like this, it should be. But in regression model, no one is going to work. You will always assume, yeah, very less people are going to work less than 10 hours a week. That is our assumption.
But other people will agree to our assumption. That is my question. I mean, we assume and we start this work.
Yeah, yeah, correct, correct.
There
So,
might be other perspective, right? So if they don't agree, it is a waste of work and waste of time. How do we prove that?
I couldn't get your question.
No, this is like based on some assumptions we are drawing some, we are starting our work. Like we are going to predict this.
Hmm.
But for the same equation or for the same data, the other people, like we have two data analysts, the other data analyst might be having a different perspective and different way to work. So how we will prove like our data, whatever we did, whatever the activity we performed on this data is correct?
Oh,
Is there any
yeah.
way or everything it goes on assumptions only?
Yeah, yeah. Suppose you come up with only linear regression, right? And so that is like, yeah. So there will be some matrices saying mean absolute error. One is, sorry, MAE. There are some other error is MAPE, mean absolute percentage error, right? So you will, based on such matrices, so for each models, you will decide, I will do one. This is, you did what? Training, right? You did training and you're able to plot this data. So what you are doing is, suppose this example, suppose till this data, this point, you take this as an input and try to plot your data, and you can do testing on this, saying that I am did not send this data. So for 80,000, what is your model is giving? Suppose it is giving 40. Sorry, other way around it is, right? Mhm. So there you have to do some testing actually. So suppose you give 37.5, but your model based on that equation put this value 37.5, you will get some y hat, right? You will write that y hat. Suppose you get 7,500 or 71,000, 7,100. For this 25, you are getting suppose 2,000 only. How much error it is calculated? So this is nothing but 2,100 minus 2,000 is your error term, right? error 1, error 2. So in that way, first you will calculate those errors, and based on that error, you can various error can come, right? Mean absolute error. Maybe you take the absolute piece only. Sometimes it is 9,000, then it will make negative, right? So you just sum the all mean and sum the error. Maybe summation of error is your lesser than the other person's model. Then you can say my model is better. So there are many matrices you will have to agree with you or your colleague or your manager saying that my model has this matrix. So he may suggest some other matrix to check. In general, whatever I understand, most of the prediction model they will use this MAP. Many of the prediction model, but it's not any hard and what to say hard and fast rule. You can choose any of the matrices to calculate the accuracy of your model and agree on it. Some people go with R square also, saying R square is better. I will prefer this model versus other model. That's all. And there are other thing also. Maybe this number, how much data you are training, it should be agreed also with your versus his, right? Other colleagues. So suppose you take lot of data or some data which is he is not training on it. So we should agree on same data set and then work together and to build some models and try to find some matrices to compare model. Based on matrices, you will find, yeah, this model is making more sense. It is having more general cases. That's all. You will go ahead with that. Yeah.
Okay.
hmm Yeah, nice question. So this is practically you will find, yeah, you will end up with plotting this linear function model, linear regression model will have. Now, second question comes into picture is suppose we have right this equation, this one, when we have multiple one. So, is it really education matter, or I should only predict using these three, or which three I use, or do I need all four or not? So this is also a second question. You will actually try to plot with x1 only, only x2, only x3, only x4. Then you will go with x1 and x2, x2, x3, x2, x4, and all the combination actually. So which combination is really giving you best income? So in our data set also, this example, I discard this. In this example also you need to check, is it really year is also impacting your selling price or not, kilometer driven is really impacting or not, so engine size is also impacting or not, which all out of this is really good predictor for your this selling price. So what is the idea is like some of the data points you can ignore also, saying diesel and fuel type is not impacting much. I can remove this data into my prediction analysis and still get a good result. So that is where we use bring these things. These analysis are very helpful actually. Finding the exact better predictor or yeah independent variables.
Okay, suppose in all the combinations we are trying to match something, we are getting a nearby college like these two are only close. So for that we can conclude like based on this factor only we are deciding the selling price. That is how.
Correct. Yeah, you
Yeah.
can say out of these five features we call in machine learning features those columns. Out of these five feature, these are four is good enough. They are actually giving you 90% accuracy. We can ignore the fifth one, or you able to find like first two is only giving 90% accuracy. You can ignore the last three. No point of using into model, right? You are wasting your computation also, and you are wasting meaning only computer computation for time being. And in future, you don't need to collect the data also for that points, right? So you can
Okay.
ignore that, but it is good to have more feature, but it's not mandatory. That is only thing. So there are comes with feature importance and all. Let's go into other example, try to understand. Here one we have is online versus GPA. How much hours he was online or something like that. I am not sure. What is this online? Yeah. Time online. Yeah. How much hours a person is spending. Suppose it's a quite old data assuming like hourly basis, some people are given to work study, given some access to remote portal and all. He spent 5 hour. A student spent 5 hour. His GPA was his or her GPA was 75. Some people actually attended like a 10-hour lecture. Yeah, you can say 10-hour lecture is 80.12 GPA. Similarly, like that. So our question is really GPA is dependent on the online time of any student? So again, you will do what? First, you will go with the plot, and now you can see GPA of any student is not actually dependent on. Kind of, it has very less trend, but you can say it is independent mostly. Yeah, not going to say. Then there will be some outlier we call in machine learning, which are like extreme and rare values, which actually can be a reason of error or very important observation. These two things, right? How I am saying the yeah. So how we define this? It's saying three standard deviation from the mean. If it is away, we call them as a outlier. How we calculate that? If you remember, we used to calculate the sigma and mean of the data, and this is like 69% of the data will fall into one sigma range. If you draw this sigma, second sigma is around 90, third sigma is around 96%. So the points which are like here or here kind of, we will call them as a outlier, third sigma. 1 sigma, 2 sigma and 3 sigma here. So something like this, we define 3 sigma and you can calculate this value, this z, or based on z actually, saying x is greater than this 3 sigma of sorry 3 sigma, and then you can call them as outlier, or it can be a very important observation. This is very much depends on the what type of data or what business problem you are solving, or then only you can take a the call like that is really outlier or it should be removed from the analysis, or is it a error. So in that case, right, you just saw this example, it is error. 200 hour a week, no one can work. You can quickly remove this. But in GPA also, these are many are like outlier. These are very strange values. They are getting around 90-80%. So in this example, we can call these two as a outlier and remove from our analysis. Then you may able to plot some relationship like lesser the hour spend on the online, greater the GPA kind of thing. It is very obvious also. You will spend more time on a study then. Kind of, not exactly, but yeah, one relationship. So then when you removed it, you will find there is a relationship now, negative relationship. As your time spent on online is lesser, your GPAs are higher. Similarly, that crude oil, if you remember the first data, you can plot it. There is kind of a higher correlation also. You might remember, right? Plus 1 to minus 1, we call correlation. We have to calculate that using formula. So towards 1, this is saying positive correlation of 0.87%. Yeah. U-shaped data is there, but it has plus point 1 to correlation. Many type of data will be there. Yes, assumption of model actually we need to cover. Yeah, that's all I have today in the PPT. We will go into like how we do this analysis. Maybe the quickly we will go, or we will try with our data better. So this is one example like how we perform regression analysis in Python. So this is very much what to okay, better I should use like this only. Can we? Oh, it did. Okay, no. So yeah, we have one data set we are using USA housing.csv. We have some information. It's giving you your neighbors information about houses in US one region and trying to predict their prices of house prices. So guess what all the features you will get house predicting house price. What type
The
of data?
located,
Yeah.
like since it's USA thing,
Yeah,
what is
we
the square feet and which side it is located to, and is it
yeah.
nearby to a highway kind?
Yes, correct. So we have this
Drainage.
data. Datas are like average income of a resident who is living in that data in the house. Sorry, how much old the house it is, age of the house, obviously, number of rooms, number of bedrooms, area population, which what is the price it is selling, what is the address. Yeah, correct. The location and address is also a factor to predict the price of the any house, obvious. In flats and all, you can go by the floor count, number of total floors, number of towers in the flats. Those are also a factor can be. And now again is like what type of who is the builder also, his income also you can bring into picture or his revenue or all. But we go to small data set, we have such information. Obviously, average area, income, average size also should be there, but I think we don't have. So we will what we will do is first we will import the libraries, then read the data. Let's yeah we can do a hands-on also. Let's we will run. Okay, it will take time to this Python to come up with. Oh, okay. Yeah, I should use this Python. So oh, okay, okay. Yeah, it's importing. Yes. Mm-hmm. Hmm. So we have all the packages, mostly I think Pandas, NumPy, and Matplotlib, and the Seaborn. These two are visualization, this for data analysis. Now this data I will also share with you guys. We have this data. Now we can check what is the data we have. So once we check, we have found this average income, number of bedroom, rooms, population, price, and address. You want to predict this. What is your independent dependent variables? This one, price, independent are all these four. You will check it has 5,000 rows. Now you will check the mean standard deviation using describe. Let's check. Yeah, you can do the pair plot using that pair plot command. You can see there is very no relationship kind of pattern is very less. I think this one, this one, this one, these three are actually kind of impacting the price. This is price only, right? In the graph, if you look closely, you will find it is price. Yeah. Oh, okay. We cannot increase this. Maybe we can use some. Yeah. Okay. No. So yeah, okay, we can see here average income, average house, and average number of rooms are actually increasing this price and average area of the population. And then, okay, what we will do. Sorry. Yeah, we were here. What we'll do again, we will actually one plot also, distribution plot, how the price is actually distributed in the data set. So we can see the price is actually starting from 0 and going till 2.5 and 6 zeros more. I think 2 lakhs, 2.5 lakhs kind of dollars. And sorry, after that you should do uh, correlation plot using this command, if you remember. So if you find this point 0.8 or more than point 0.8, that is like, or maybe 0.75, you can say those two are correlated. And in this data set, we can see here, if we plot this, yeah. Okay, point 0.8 is this one. You can see this one is more better correlation. And after this, we want to train the regression model. So
Rishi, can you stop at the, oh, what is it, model? Above. Can you go still up? There was one graph.
yeah, okay. Why it is not going up? Yeah, this one.
No, the colored one, like the heat
Yeah.
map. Here, 1.0. So
Oh,
whichever
it's
is coming
again,
mean,
yeah, other way around. It got plotted somehow. So lighter the color, it's good. Darker is the color is bad. So we actually looking for price, right? You can see orange is also good. So for price, what we can say, average income is good, and average houses is also kind of greater than 50 maybe. And I think average number of rooms, it is less than. And there was one more way to actually plot this values also, right? You just remember that syntax. uh,
labels. No, that is
no,
fine.
we used to plot the numbers also, right? Annotation equals to true
And
something. Annote equals to true.
note.
Yeah, no, it is saying error. Actually this
AN and OT, I think there was two values.
mhm, it should be inside this. No, it is not.
Dot annote or it's like comma annote.
Wait, we can check. Yeah, annotations in heatmap. No, these are very strange. We need the inside values, okay. But this is for which book? In, yeah, Seaborn. We should check, yeah. Oh, it's just half. Now here, yeah. So you can see the values now. Based on this value, you can see the last column is also price. So you can see here 0.64. So obviously 64%. This is very much correlated with average income 45%. I think average number of rooms is very less correlated, but also area of population is kind of 40% correlated. These values, based on these values, we can say price is somewhat correlated to all this data except area of number of bedrooms. That's all. So now what is like your price was independent. All four can, as of now, all five you can take as a independent variable. Let's see how the model pred works, and then you can play around and remove some of the column. So here address we are not taking into consideration, it has text information. So you cannot use actually. You can use how you can use actually. Suppose you can take some reference in that graph, try to plot that somehow. I am not sure. Based on address, you can get the lat long, and then maybe that is the see. This is actually where your data analysis skill can come. Take the address, get the lat long, take any reference or center point out of those lat long, and then you can calculate the distance and make another extra feature. So this piece, whatever I just told, this we call it feature engineering. We created a new feature based on some data which we already have.
Feature engineering.
Yeah, that is also a term in machine learning. This is, but yeah, you are not going to do, someone can do for you, or maybe you can also try and come up with this feature, extra features. Maybe then in future also you can check like average income and houses and number of fish and bedroom. Somehow you can club this and create new feature also, meaning saying average income, square of it, and age also you can square it and take the ratio. Come up with one more new column saying ratio of square of area of income to the house age, and create one more new feature and try to check is it really making sense with the price. These types of also feature engineering or new feature creation you can do. But for time being, we will go with this four of the, sorry, five of the columns and try to split. So there is one more classic step. You have to split the data into train and test. First step is like, meaning when I said right, this model should be tested also. So we in the machine learning, you already have some libraries which can do for you. And here actually when you set test size as 0.04, you are saying I need only 40% of the data as training set, and sorry, testing set, and remaining as testing set. This is also machine learning steps. And random stage is some number, random number you have given to train your model. Split your data set actually. This is splitting. So it will, what it will do, randomly give 40% of the data here and some 60% in the train actually. Train will be this one, test will be this one. Just remember this, and then
Yes,
actually,
syntax. Like
yeah,
a common used syntax. This one, X train, Y train.
correct, correct. So you can see X is like here. How you decided X? All the columns which are independent variable, Y as dependent variable. And see, in the end, you have to do this. Then only you can say my model has some relationship. I can able to find some relationship and be able to plot regression plot. You can, how you will call sklearn will have this library. Let's we can also do this. We just run this. Yeah, kind of it later on. These libraries also have examples. You can go through them. And this, see how LM we say linear model regression, linear regression. We call this libraries class, and we, yeah, call this fit method on X train and Y train. What it will do, it will try to fit for you. It will may take some time, but for time being it is not taking. When we call this LM intercept, it is nothing but the same B, what we used to say B naught. Okay. And coefficient also, when you call this, you will get, because remember now you were in this one, actually you are doing multivariate, remember.
Yes, bivariate and
Yeah,
multivariate.
bivariate and multivariate. So instead of b1, we will have many four values b1s, right? Or four or five. So in this case it is these five values. You can put these values, and based on some new data you can check also. And this is in how you can read it. It is saying average one increase in this, it is saying increase of the price is $21. That is how you should interpret this coefficient. Okay. I can show you the values. It is saying by the increase of one area size, average size income, sorry, $21 is the increase in your house price. If average house age 1 year it is changing, suppose ages will be I think in years, then it is I think 1,64,000, it will increase. Meaning your 5 year old house is there, now it is 4 year old, so it will have this value. If a number of rooms you will increase, then you will have a gain of some 12 lakhs, sorry, 1,22,000 dollars, something like this. You can, I will share this, you can read and rerun and try to understand more. And yeah, I was saying how to evaluate the model, right? Let's check that also. After that, you can do the prediction, try to plot them. So, so prediction is nothing but you will call on X test, right? These are like what we, when we say like that X train and X train test, Y train and Y test. What we are doing is we are not training the model with the remaining 40% of the data. What we do is we predicted the 40%, we did the plot of that. This is original data. This is your model predicted. So where is your model predicted? You will check.
Y test is on 40 original values and predicted one we are trying
Is
to plot.
using the
Is it
model,
that way?
yeah. And you can see they are not exactly same. Even if it is same, it should be coinciding each other and it should be on very straight line. But you can see there are some deviations. So based on that deviation, you can see, actually we used to say is we do the residual plot of error. This is error actually. Y test minus your prediction. So you can say this error is normally distributed. When we get this normally distributed error, we call this model as a correct model. And our error term should be normally distributed. That is our one more assumption in linear regression. And these are all the matrices you can calculate. I was saying, right? I was saying my MAP and dot. Sorry, yeah, MAP. But yeah, there are also other mean squared error you can calculate. And similarly, you can calculate this root square mean. Yeah, mean squared error. I think you can see what is the reason why we calculate different types of this. And the idea is it all the matrices or loss functions should be minimized. Then yeah, just code this values. How in this library, see everything is for you already there. Many of the things you just have to tell the interviewer, I will calculate these to compare my models. In case he asks the formula, you should remember how we calculate the y hat is the predicted one, y is the actual one. So actual versus predicted. I'm not going into maths. I think yeah, not
Yeah,
required
this
much.
SK learn is like what kind of library, Rishi?
Yeah, that is machine learning libraries,
Oh,
sklearn, Python. That is also you should know how to use it. Just go to I think some tutorial, small ones, and while doing this, you should know also these three methods: classification, clustering, and regression. How we do it, and inside that, all the libraries or all this everything is already there. You just have to use it. You should know how to use them. Yeah, that is only your purpose should be. You can go to examples, learn, and just now we talked only one regression, right? If you remember, there are many. When I say many, I think it should have somewhere they have actually generalized regression model. So you can see sklearn will have a lot of see rest classifier, logistic is there, linear is there, and then elastic net, lasso, cv, all this library will have some features. Different linear models and regression models are there. Yeah, so they will have some other matrices to also plot f score, Hamming laws based on the data set, and like different model will have different types of matrices. You can see regression matrices, max error, mean, MSE, log error, median error, mean percentage error. This is what I was asking. May R2 square, mean Poisson. Many are already coded for you. You just have to pass the correct way to this one. I heard this first time. Pinball loss for quantal regression. So what type of regression you are using, what type of matrices you have to use, you only decide. You are the meaning owner of this modeling, so you only decide, and you can ask help also, like who is actually assigning your job and all. So that's all I have for today. Regression, this is one of the topic we had in this course to cover. I think regression modeling, I think, yeah, last one was reducible analysis. There are some properties we can discuss maybe tomorrow or day after in the next class. And one more we need to understand is clustering. Yeah, that's all. Two topics. And instead of this demand forecasting in this linear, what is this retail industry? We are doing that car prediction right now using linear. If we go logistic, we can check this data to do logistic regression. For today,